very, very familiar with are three tables in your reference tables P, Q, and R. These are huge helps for the organic that we need to learn and master this year in chemistry. So we build everything off of the three simplest homologous series of hydrocarbons. So homologous means that every molecule within that series, it changes by the same factor. Now, hydrocarbons, these are our simplest organic compounds because they only contain hydrogen and carbon. It's very simple and very straightforward. So hydrocarbon, hydrogen, and carbon only. On table Q, it provides you information for the three hydrocarbon series that you need to be able to work with, identify, classify, draw structures of. And their names are really similar. So we have our alkanes, so A-N-E. We have our alkenes, E-N-E. And we have our alkynes, I-N-E. So it makes like an I sound. The homologous series. Every member in the alkane group, its number of carbons, so N is your number of carbons, the hydrogens will always follow this formula, 2 times N plus 2. Okay, so now take a look. Here is a very simple alkane. So what we notice is in this structure, there are 2 carbons and they are linked together with a single covalent bond. And because the carbons, the backbone of the structure, are linked together with single covalent bonds, that is the ane part of this. When we take a look at the next structure, we still have 2 carbons in this molecule, but this time those carbons are linked together with a double bond. So a double covalent bond. And because there's at least one double covalent bond between the carbons, the backbone of the structure, that is where the ene comes in. And our last example here, we still have 2 carbons that make up this molecule, but instead of it being a single bond or a double bond, we have a triple covalent bond present. And if it's a triple covalent bond in the structure, we're going to see the name end with an "-ine". Now notice these names. You have ethane, ethene, ethyne. So the difference in the name is the ending, the suffix, ane, ene, or "-ine, because it tells us about bonding that we should see within the structure. But the eth part, okay, there's always everything in an organic name for us will tell us something about the structure, because this carbon chain, this parent chain, so the parent chain, PC, contains 2 carbons. Notice in the next molecule, the parent chain, which I'm circling, also is made up of 2 carbons. So that's where the eth comes from. And lastly, the ethyne, when you look at the structure, there are only 2 carbons in the parent chain. So it's a 2-carbon parent chain. So it's also an eth. So the eth tells us, or the prefix tells us the number of carbons that we can circle, and the ane, ene, or "-ine tells us the type of bonding that we can expect to see. So here we go. You are given a molecular formula like these. So these are just simple molecular formulas. They tell us the element that's present, each element that's present, and how many of each. And what you need to classify looking at these molecular formulas, is it an alkane, alkene, or alkyne? So we're going to use the formulas given here to figure out the classification. So use the formula that's given. Okay, So the number of carbons, whatever carbon subscript is, that is N. And if you notice, each of the general formulas for hydrogen all start with 2N. So in this case, N equals 3, because that's carbon's subscript. So 2 times N, which is 3, and it has to equal the total number of H's. So that's our total H's. So it needs to equal 8. Well, 2 times 3 does not naturally equal 8. 2 times 3 is 6. To get to 8, I have to add 2 more. So 2 times N, and if I have to add 2 to it, then I understand it's an alkane. So I would classify this as an alkane. So this would be 2N plus 2, 2N, and this one is 2N minus 2, just copying down the formulas from up above. Okay, so the next example, N equals 4, because that is carbon's subscript. So 2 times 4, the total number of hydrogens that I need to have present mathematically is 6. 2 times 4 does not naturally equal 6. 2 times 4 is 8. So to get to 6 hydrogens only, 2 times 4, which is 8, minus 2 will now equal 6. So now that I had to subtract 2 from the product, I understand it's an alkyne. Okay, looking at another example here. Here's my N. So N equals 11. So it's 2 times 11. And my total this time has to be 22. And 2 times 11 naturally equals 22. I don't need to add 2 or subtract 2 from this product. So I understand that this is the alkene. Another example. So here, 12, the subscript of carbon, that is my N. So N equals 12. So 2 times 12, and my total has to equal 26. Well, 2 times 12 is 24, so it's not quite 26. To get to 26, I have to add 2 to it. So when I have to add 2 more, I understand that this belongs to the alkane family. Last example here. Carbon subscript is 13 this time, so N equals 13. 2 times N, the value of 13, and in this case it needs to equal a total of 24. Well, 2 times 13 is 26, which is not exactly 24. To get to 24, I have to remove 2 H's. And because I have to subtract out 2 H's, that makes this an alkyne.